Hello everyone, welcome to Brain Blitz Audios. In this episode of NEET preparation, we'll be looking at previous year questions of medical entrance examinations in India. We'll be looking at the chemistry syllabus of grade 11 CBSE. The first chapter of this syllabus is Some Basic Concepts of Chemistry, and that's the chapter that we'll be dealing with. Let's look at our first question. The weight of a single atom of oxygen is. We have four options and we need to find out which of these is the right option. So we need to find out what molar mass is in order to do this question. So molar mass is the mass of 1 mole of an element, say in this case oxygen, in grams. So this is expressed in grams and it is the mass of 1 mole of oxygen. So for oxygen, the molar mass is 16. So that stays the same. So it can be calculated as weight of 1 atom of oxygen times number of atoms in 1 mole of oxygen. So that is molar mass. Therefore, we can find the weight of 1 atom of oxygen, weight of 1 atom of oxygen will be equal to molar mass divided by number of atoms in 1 mole of oxygen. That will be equal to 16 divided by Avogadro's number. And Avogadro's number is 6.02 into 10 raised to 23. Now, 1 by 10 raised to 23 can be written as 10 raised to minus 23 times 16 by 6.02. Let's simplify this by multiplying both the numerator and the denominator by 100. So we'll get 1600 divided by 602 into 10 raised to minus 23. So let's do the division. 1600 by 602. So 600 times 2 is 1200. 600 times 3 is 1800. So let's take 2. So 1600 minus 602 times 2 is 1204. That is simple multiplication. So 6 becomes 5. This is 10, becomes 9, and this is 10. 10 minus 4 is 6. 9 minus 0 is 9. 5 minus 2 is 3. And 1 minus 1 is 0. Now, we need to divide 396 by 602, but that's not possible. So let's put a point here, which indicates that the next numbers onward will be decimals. So when we do that, we can add a 0 here. So it's 3960 divided by 602. So when we do 602 times 6, 12, 1, 36, and if we do 6 times 7, that goes into the 40s. So we can put 6, 2.6 minus 3, 6, 1, 2, 5, 10. 10 minus 2 is 8. 5 minus 1 is 4. 9 minus 6 is 3, 0. So we have 2.6 and some remainder left. But we don't need to calculate that, because when we go back to our options, we find that option 3, 2.656 into 10 raised to minus 23 grams is the closest option. So therefore, we can safely conclude that option C is the right answer. So the right answer is 2.656 into 10 raised to minus 23. So over here, on the first step of division, we get a 2. So we'll be able to identify that the weight of a single atom of oxygen will be 2.656 into 10 raised to minus 23. So that's how you solve it faster during the exams. Just divide and get the first one or two terms until you can differentiate between the options. Our next question. Volume of a gas at NTP is 1.12 into 10 raised to minus 7 cubic centimeters. The number of molecules in it is 3.01 into 10 raised to 12, 3.01 into 10 raised to 18, 3.01 into 10 raised to 24, or 3.01 into 10 raised to 30. So we have our volume is equal to 1.12 times 10 raised to minus 7 cubic centimeters. So one mole of gas occupies 22,400 milliliters of volume, and milliliters is the same as cubic centimeters. So that means 22,400 cubic centimeters contains 6.02 into 10 raised to 23 molecules. So 1 cubic centimeter will be 6.02, contains 6.02 into 10 raised to 23 divided by 22400 molecules. And since our volume here is 1.12, we can safely conclude that 1.12 into 10 raised to minus 7 cubic centimeters contains 6.02 into 10 raised to 23 times 1.12 into 10 raised to minus 7 divided by 22400 molecules are present. So that is our calculation. It can be expressed as number of molecules in V liters of gas will be equal to V times NA. So V is the volume, 1.12 into 10 raised to minus 7 times Avogadro's number, 6.02 into 10 raised to 23, divided by 22400, because we're expressing it in cubic centimeters. So let's put in the values. 1.12 into 10 raised to minus 7 times 6.02 into 10 raised to 23 divided by, now we have 22400 as the denominator. But if you notice, only 2, 2, and 4 are significant figures. So therefore, we can write it as 2.24 into 10 raised to 4. So 1, 2, 3, 4. Now what do is we simplify the powers. So 1.12 into 6.02 divided by 2.24 into 10 raised to. So we have 23 at the numerator minus 7. And since 4 is at the denominator, it becomes, so 10 raised to 4 will become 10 raised to minus 4 when taken to the numerator. So minus 4, which will be equal to 1.12 into 6.02 divided by 2.24 into 10 raised to 12. 23 minus 7 plus 4 is 11. 23 minus 11 is 12. So that's why we got 10 raised to 12. So the next step is to look at this part. So when you multiply 112 twice, you get 224. And it's basically the same scenario here except with the decimal. So 1.12 goes into 2.24 2 times. So that will be 6.02 divided by 2 into 10 raised to 12, which is equal to 602 divided by 2 is 301, so 3.01 into 10 raised to 12. That is our answer. And when you go back, we find that option A is the right option because that contains the right power, 10 raised to 12, even though all the others had 3.01. So in this question, by reaching this step, okay, let's go back. By reaching that step, you'll be able to identify the right option, which is option A, because that had the right power. Next question. The oxide of an element contains 67.67% of oxygen, and the vapor density of its volatile chloride is 79. The equivalent weight of the element is 2.46, 3.82, 4.36, 4.96. So the oxide is composed of the element plus oxygen. And so it's given that 67.67% of the oxide will be oxygen. That means that 100 minus 67.67%, which is the remaining percentage of the oxide, will be composed of the element. So 100 minus 67.67 would give you 32.33% of the element. So the percentage of oxygen is 67.67 and the percentage of the element is 32.33. Now we have to find the equivalent weight of the element. So the equivalent weight in terms of the oxide is defined as the number of parts by weight of the given substance which combines or displaces 8 parts of oxygen to form an oxide. And the 8 parts mentioned here is with respect to weight. So when we look at this question, we find that we have given percentages of the oxide and we found out the percentage of the element. So what we can do is we can take the oxide as 100 grams. So you can just put the value of the percentage as the mass of each component. So that says in 100 grams of oxide, 67.67 grams of O2 reacts with 32.33 grams of the element. Therefore, 1 gram of oxygen reacts with 32.33 divided by 67.67 grams of the element. So this is one part of oxygen. And in our question, we need to find the equivalent weight, which is the number of parts by weight of given substance, which combines with 8 parts. So here we have to multiply that by 8. So 8 grams of O2 reacts with 32.33 divided by 67.67 into 8 grams of the element. That is the equivalent weight. So on calculating, 32.33 times 8 divided by 67.67. And so 32.33 times 8. So we'll do the multiplication first. So I'm going to do it from the left side. So 3 times 8 is 24. So 3,000 times 8 is 24,000. 2 times 8 is 16. 200 times 8 is 1600. 3 times 8 is 24. 30 times 8 is 240. And 3 times 8 is 24. So this is comparatively easier because then you need to do addition. So 4, 6 plus 2 is 8, 4 plus 1 is 5, and 2. So we get 32.33 times 8 as 258.64 divided by 67.67. So now let's do the division of 258.64 divided by 67.67, which we can equate to 25864 divided by 6767, essentially multiplying both the numerator and the denominator by 100, which is still the same value. So on dividing, 25864 divided by 6767. So let's do multiplication. So 6767 times 3 gives 18,000, 2100, 180, 21. So that'll be 1, 0, that's 1 coming here, 3, 0, 2. So times 3, we'll get 20301. 4 minus 1 is 3, 6, 5, 5, 0. Now, we should be continuing further, but when you're looking at our options, we find that option B only has a 3 at the units place. All the others have 2 and 4. So by doing that much, we can find out that the equivalent weight of the element will be option B, 3.82, without having to do some more messy calculations because of our options. Next question. 60 grams of an organic compound on analysis is found to have carbon as 24 grams, hydrogen as 4 grams, and oxygen as 32 grams. The empirical formula of this compound is. How do you find the empirical formula if you have the mass of the given elements? So let's do a table here of the elements C, H, and O. The first thing that's given to us is the given mass. Given mass, C has 24, H has 4, and O has 32. On adding them, you still get 60. So that is correct. Now, what we do is we find the number of moles. And number of moles, when you have the given mass, will be given mass divided by molar mass. So yeah, given mass is 24, molar mass of carbon is 12, which will be equal to 2. So there are 2 moles. 4 divided by molar mass of hydrogen is 1, so that is 4. And 32 divided by molar mass of oxygen is 16, which will be equal to 2. So we have 2 moles of carbon, 4 moles of hydrogen, and 2 moles of oxygen. Now we convert it to the simplest ratio. The simplest ratio of the elements. So if you look at 2, 4, and 2, we can simplify that by dividing by 2. So 2 by 2 is 1, 4 by 2 is 2, and 2 by 2 is equal to 1. So we have, the empirical formula will be equal to 1 carbon, C, 2 hydrogen, H2, 1 oxygen, O. So the empirical formula is CH2O, which is option A. So option A is the right answer. So when you're given these amount of the carbon, hydrogen, and oxygen of an organic compound, the empirical formula given is CH2O. That is the right answer for this question. Our next question. The molar concentration of 20 grams of NaOH present in 5 liters of solution is 0.1, 0.2, 1, or 2 moles per liter. So let's look at the question first. 20 grams of NaOH is the given mass. So it's convenient to know the molar mass. So molar mass of NaOH will be 23 plus mass of oxygen is 16 plus 1. That will be equal to 40 grams. And the volume is 5 liters. Now, let's look at the term molar concentration. This is the same as molarity. So molar concentration is molarity, and the molarity can be expressed as the number of moles of solute divided by volume of solution in liters. And to find the number of moles, we write it as given mass divided by molar mass. So that gives us the number of moles, and we divide this by the volume of the solution in liters. So here our given mass is 20 grams divided by our molar mass is 40 grams for NaOH, and the total volume is 5 liters. Molarity. So what we do is we take it as 20 divided by 40 times 5. So that's how you convert this statement. So 20 by 40 whole divided by 5 will be equal to 20 divided by 40 into 5. So 20, so that will be equal to 20 divided by 200. 40 times 5 is 200. And 20 is common to both. So 20 times 1, 20 by 20 is 1. And 200 by 20 is 10, because 20 times 10 is 200. So the molarity will be equal to 0.1. And since it's the number of moles per liter, we'll get it as moles per liter. And this unit is also expressed as molar, which is denoted by capital M. Therefore, the right answer for this question is option A, 0.1 moles per liter. And we got that after calculating for molarity. Molarity is number of moles of solute divided by volume of the solution in liters. Next question. The normality of the solution obtained by mixing 10 ml of N by 5 HCl and 30 ml of N by 10 HCl is N by 15, N by 5, N by 7.5, or N by 8. What is normality? Normality is the number of gram equivalents of the solute dissolved per liter of solution. So it basically is gram equivalent divided by volume in liters for a solution. But here we're mixing two solutions. So the normality obtained when the normality on mixing two solutions of the same substance, which here is HCl, is given by the formula N1 V1 plus N2 V2 is equal to N into V1 plus V2. N1 is N by 5 HCl, N2 is N by 10 HCl, V1 is 10 milliliters, V2 is 30 milliliters. And so those are the components. So from that formula, we can get the value of normality as N1 V1 plus N2 V2 divided by V1 plus V2. N1 is N by 5 times V1 is 10 plus N2 is N by 10 times V2 is 30 divided by 10 plus 30. So let's simplify. 5 goes into 10 2 times, 10 goes into 30 3 times, and 10 plus 30 is 40. So this will be simplified as 2n plus 3n divided by 40, which will be equal to 5n divided by 40. So that, on simplifying, so since 5 goes into 40 8 times, we'll get n by 8 as the normality of the solution. And if you look at our options, we find that option D is the right answer because it is given n by 8. And on calculating, we got the normality as n by 8. Next question. The empirical formula of a compound is CH2O. The molecular weight of this compound is 180. The molecular formula of the compound is. So to get molecular formula, we need to find empirical formula mass. So we put the molar mass of each of the component in the same order of the empirical formula. So C, that is 12, plus 2H, that is 2 into 1, plus O, that is 16. So that it's 12 plus 2 plus 16, which will be equal to 30 grams. So this is the empirical formula mass. Now what we do is we divide molecular mass by empirical formula mass. So we get N as molecular mass divided by empirical formula mass. Molecular mass is 180 divided by 30. On simplification, we can discard the zeros to get 18 by 3. So n is the ratio, basically. So 18 by 3 will be given as 6 because 6 times 3 is 18. So n is equal to 6. So to get the molecular formula, we multiply n to empirical formula. So the molecular formula will be equal to CH2O 6. So C6H12O6 is the molecular formula. This is the molecular formula of glucose, by the way. So the right answer is option C, C6H12O6. So the molecular weight of glucose is 180. Most people memorize this, so when they come into the exam, when they see the molecular weight is 180 and the formula as CH2O, they'll quickly write option C. But this is the right steps in finding out how it is C6H12O6. Next question. 0.4 moles of HCl and 0.2 moles of CaCl2 were dissolved in water to have 500 milliliters of the solution. The molarity of the Cl- ion is. So here we're asked to find only the molarity of Cl- ions, and it's kind of a little different than what you'd expect. Let's solve the question. So HCl in water will dissociate into H plus Cl minus. So 1 mole of HCl will give 1 mole of H plus and 1 mole of Cl minus. Therefore, 0.4 moles of HCl will give 0.4 moles of H plus 0.4 moles of Cl minus. We'll mark this. Now, the next compound, CaCl2. CaCl2 on dissociation will give you Ca2 plus 2Cl minus. This is a bivalent cation and the anion is monovalent, so there'll be 2 Cl. So if there's 1 mole of CaCl2, they'll give you 1 mole of Ca2 plus, but 2 moles of Cl minus, according to the formula. So 0.4 moles of CaCl2 gives 0.4 moles of Ca2 plus not 0.4 because it's given as 0.2. So let's redo it because this statement is incorrect. Let's start again. So it's given 0.2 moles of CaCl2. So it'll be 0.2 moles of CaCl2 will dissociate to give 0.2 moles of Ca2 plus 2 into 0.2 moles of Cl minus. This will be equal to 0.4 moles of Cl minus. So from both compounds, we get 0.4 moles of Cl minus, respectively. So number of moles of Cl minus will be equal to 0.4 plus 0.4, which will be equal to 0.8. We're asked to find the molarity, and molarity will be equal to number of moles of solute divided by the volume of the solution in liters. So we have 0.8 moles and 500 milliliters, which can be easily converted into 0.5 liters. So 0.8 divided by 0.5 moles per liter. So we can just multiply by 10 on both sides to get 8 by 5. So, and this unit will be molar, and 8 by 5 will be equal to 1.6 molar. That is simple division. So the right answer is option A, no, that's not the right answer. The right answer is 1.6. So when we look at our options, we find that option B is the right answer, 1.6 molar. 1.6 molar. Next question, 10 raised to 21 molecules are removed from 200 milligrams of CO2. The moles of CO2 left are all of these. So we're given 10 raised to 21 molecules and 200 milligrams of CO2, but we have to find the moles of CO2 left. So these have to be converted into moles. So that's what we'll do first. So number of moles for 200 milligrams of CO2 will be equal to given mass divided by molar mass. That is equal to 200 milligrams. So we have to convert it into grams. 200 divided by 1,000 whole divided by 44, which we'll get as 200 divided by 1,000 into 44. 200 grows into 1,000 5 times, so we'll get 1 by 5 into 44. So 44 times 5 is 220. So 1 by 220. We have to do the division of this. How do you do this division? That is simple. Let's multiply 1,000 to the numerator. So we have to multiply 1,000 to the denominator as well in order to make it equal. So 1,000 by 220 into 1 by 1,000. 1 by 1,000 is 1 by 10 raised to 3, which is 10 raised to minus 3. So we'll get 1,000 by 220 into 10 raised to minus 3. Canceling the 0, and now we'll divide 100 by 22. 22 times 4 is 88. That gives you 12, and point, a 0 is added, and 22 times 5. So that'll be 110, gives you 10. So let's stop there, and we'll write the number of moles of 200 milligrams of CO2 as 4.5 into 10 raised to minus 3 moles. So this is the first part. Now let's look at the second part. We know that 6.02 into 10 raised to 23 molecules give you 1 mole. Therefore, 1 molecule will be equal to 1 by 6.02 into 10 raised to 23 moles. Therefore, 10 raised to 21 molecules will be equal to 1 by 6.02 into 10 raised to 23 times 10 raised to 21 moles. So this is a simple calculation. So it's basically 1 by 6.02 into 10 raised to 21 minus 23 gives you minus 2. And 1 by 6.02 can be taken as 100 by 602 on multiplying both sides into 10 raised to minus 2. Let's multiply the numerator by a 10. So it'll be 1000 by 602 into 10 raised to minus 3, because there'll be a 1 by 10 remaining. That'll be 10 raised to minus 1. 10 raised to minus 1 minus 2 is 10 raised to minus 3. And yes, we can divide that. 1000 by 602, 1602 gives you 3980. 398 point will give you a 0, and then 6, and that is 3612. 602 times 6 is 3612, and then we'll get 0368. So we can stop there, so we'll get 1.6 into 10 raised to minus 3. Now let's calculate the number of moles left. So that will be number of moles of 200 milligrams CO2 minus number of moles in 10 raised to 21 molecules of CO2. So basically it is 4.5 into 10 raised to minus 3. That's what we got here. Minus 1.6 into 10 raised to minus 3 moles. Let's take 10 raised to minus 3 common. So 4.5 minus 1.6 into 10 raised to minus 3 moles. So 45 minus 16, 3, 15, 9, 2. So that we'll get 2.9 into 10 raised to minus 3 moles. And when we look at our options, we find that the closest value to 2.88 is 2.9 is 2.88. That is option A. Now, you don't need to be afraid, because 2.88 can be converted into 2.9. So it's basically the same. So the right answer is 2.88 into 10 raised to minus 3 moles of CO2 left. Let's mark that answer and move on to our last question. The weight of NaCl decomposed by 4.9 grams of H2SO4 if 6 grams of sodium hydrogen sulfate and 1.825 grams of HCl were produced in the reaction is one of these 4 options. So to attempt this question, we should know the reaction NaCl plus H2SO4 gives NaHSO4 plus HCl. So we are given that the mass of H2SO4 is 4.9 grams. The mass of NaHSO4, sodium hydrogen sulfate, is 6. And the mass of HCl is 1.825. Let's consider the mass of NaCl as X. How do you solve this question? Using the law of conservation of mass. What does the law of conservation of mass states? Mass can neither be created nor be destroyed in a chemical reaction. What that means, mass of reactants will be equal to the mass of products. So on applying the masses, we'll get X plus 4.9 will give you 6 plus 1.825. So X plus 4.9 grams will give you 7.825 grams. Therefore, X is 7.825 minus 4.9 grams. So 7825, 4900, 5, 2, 6, 18 minus 9 is 9, and then 6 minus 4 is 2. So x is equal to 2.925 grams. And if you look at our options, we find that option C, 2.925 grams, is the right answer. And so that concludes this episode of NEET preparation. We hope you find this episode interesting and informative about the chapter Some Basic Concepts of Chemistry. For more of such useful content, please subscribe to our channel Brain Blitz Audios. We'll be back with more informative and interesting content such as learn words, mind maps, NEET preparation, etc. Until then, take care, stay safe, ta-ta for now.